All right, greetings everyone. Welcome to the second part of the video for section 4.5, continuing on with our studies of the graphs of log functions. And here we'll be looking at writing the equation of the graph of a log function. So given the graph, find the equation. Okay, before we do that, we first need our kind of general form for transformed versions of logs. So we have two formulas we'll be looking at. So the first we have there is f of x equals a times log of x minus b plus k. And the second one is f of x equals a times log of minus of x minus b plus k. It says if horizontally reflected, and I'll come back to that. Where in both of those formulas, x equals b is where the vertical asymptote is. So this value for b here will always be one we can identify fairly quickly by just looking at the location of the vertical asymptote. Now let's talk about the difference between these two formulas and when they're used. And to do that, I first want to remind us that when we looked at the graph of just a general log function that had not been transformed, what we saw is that it had a vertical asymptote on the vertical axis. So at x equals 0, if that's our input variable. And then the graph kind of ran along that vertical asymptote and then shot off to the right. Okay, so you can see that it's going towards infinity off to the right. So that's what the graph of a log function traditionally looks like. However, if it's been horizontally reflected, so we're looking at the second case here, that means it's been reflected over that vertical axis, which means the graph is going to look something like this. And now notice that the part that is going to infinity is shooting off to the left. Okay, so that'll be our marker for whether or not a log function has been horizontally reflected. If its part shooting off towards infinity is going to the left of the asymptote, then it's been horizontally reflected. If it hasn't, then it would be not horizontally reflected, and we would use this first formula over here to find the equation. All right, so let's look at an example. So here, we're asked to write the equation of this logarithmic function in the graph, and first of all, big issue with this graph, there should be arrows on the ends. And notice that it also looks like there's probably a vertical asymptote here at x equals 4. And notice that the graph from that asymptote shoots off to the left, right? And so because it shoots off to the left, that tells us that it has been horizontally reflected, which means when we go to write the equation, we need to use the form f of x equals a times log of minus x minus b plus k. All right. So we'll work with this. And note, as we talked about on the last slide, this value for b, that comes from where the vertical asymptote is. So we would know that our equation will have the form f of x equals a times log of minus, in this case, x minus 4 plus k. Now to finish this, we need to find the values of k and a. Unfortunately, there's no simple way to do this. So what we're going to do is set up some equations here. In order to do that, we first need to find some points here on the graph that are fairly easy to read. So maybe like this one here, negative 2, 2, and also 2, 0, looks like are ones we could use. So we'll plug both of those in. So we have negative 2, 2, and 2, 0. And actually, I'll do it this way. Set up my first equation by plugging in 2, 0. So that means we're going to set up at 0 equals a times log of negative of x, value for x is going to be 2 minus 4 plus k. We can actually do some simplifying here. This would be 0 equals a times log 2 minus 4. Inside the parentheses there, that gives us -2, but then we have the minus sign on the outside, so that's be minus minus 2, which should just be positive 2, plus k. All right, so we have that formula from the first point. And then we'll set up an equation using the second point, so that -2, 2. So that'll look like 2 equals a times log minus, we'll have -2 minus 4 plus k. Simplify on the inside there again, so -2 minus 2, or excuse me, -2 minus 4 is -6. Negative on the outside makes it a +6, so we'd have 2 equals a times log of 6 plus k. All right, and now we have two formulas, so this one here and this one here. And notice that we have two variables, right? We have an a and a k. And so what we might do, just kind of like we did with exponential functions, is solve for one of the variables in one of them. And I think in the first formula, it's going to be easy to isolate k, so we can subtract a times log of 2 from both sides. Okay, when we do that, these will cancel. End up with k equals -a times log of 2, and I apologize, that's hard to see. It says -a times log of 2. And what we can do now is take that value, or take that equivalence there, plug it in for the value of k in the other equation. All right, so I'm going to go ahead and erase a bunch of stuff here because we need some space. So what this second equation will look like now, once we plug that in, is we will have 2 equals a times log of 6, and plus the value for k, but we're inputting -a times log of 2. And now what we have is an equation that only has an a in it, so we should be able to solve for that. And one way we can do that, notice that both terms here have an a, so we could factor an a out. This becomes 2 equals a times log of 6 minus log of 2. But here now we have a log minus a log, and we know that we can rewrite that using our log properties. This becomes 2 equals a times log of, we can divide 6 and 2, which will just become 3. So this becomes 2 equals a times log of 3. We can solve for a then by dividing by log of 3 on both sides. Okay, and these will cancel. And then again, I need to erase some stuff here to make some room. So it looks like we get that a equals 2 divided by a log of 3, which we could then plug in the calculator. And we'll get 4.192, looks like. All right. Then we need to find the value for k. And if you recall, just a second ago, we had this formula where k was equal to -a times log of 2. So we can go ahead and plug in the value for a there. I'm going to use this exact value, so the 2 over log of 3 that we had before we found the decimal answer. So if we do this, this becomes the negative of 2 over log of 3 times log of 2, which if we now plug that into our calculator, that we end up with is negative 1.262. Okay, so now we have the values for both a and k. We can plug them into our equation up above to finally write the full formula for this function here. I should also mention we have the value for b as well. We had that from the vertical asymptote. So this will become f of x equals 4.192 times log of minus x minus 4 minus 1.262. Okay, and that, my friends, will be our equation. And we could, of course, check that this is correct by taking what we got there, graphing it, and seeing that it looks like the graph we started with. All right, that's all for now. Thank you for watching.